Welcome to this Blackmagic AI tutorial on using the Tiny-Yolo 3 object detection algorithm on the Raspberry Pi. Once again, you can go to blackmagicai.com, like us on Facebook, and subscribe to our YouTube channel. Alright, so first a few prerequisites. You need a Raspberry Pi 3 Model B, TensorFlow 1.11, Keras 2.24, and Python 3.53. So these should be already installed on your Raspberry Pi. You can try other versions if you want, but this is what the tutorial uses and this is what we know works. TensorFlow 2 may not work because this was done long before that was released, so stick with what's here. Alright, so in this tutorial we're going to go over cloning the Tiny-Yolo 3 repository on the Raspberry Pi. We're going to create a .h5 file, which is the model that we'll create using the Colab notebook. We'll download that file and then we'll run the YOLO main Python program to test it and show you how to use the model. Alright, so first we're going to go to our Raspberry Pi desktop. We're going to open up a browser and we're going to type in blackmagic.ai.com and that will take us to the website. That will be the starting point for going to all the different parts we need. Alright, so this will land us on the landing page. And then what we'll have to do is scroll down to the bottom. Here's our portfolios. You can browse those if you want. But we'll browse down to the bottom of the page and go to the social media bar here and see where we'll click on the GitHub link. So that'll take us to the GitHub page. So here it has another link back to the website if you need to. And then we're going to click on the repositories, and then there's Tiny-Yolo-3. So that's the repository we want to clone. So if you click on that, that should open up the repository so we can see it, and these are some of the files in that repository. So we have the notebook, which we'll use later, but the main thing we need is the examples folder. So we're going to copy this link so we can clone it. So you click on the green code button and that'll bring you up the link so we can do the clone. So now I open up a terminal on my Raspberry Pi and I listed my current directory, so I guess I'm in home. And I'm going to do git clone, type that in, and then I'm going to paste that link that we got from the GitHub page, repository page. And all it's going to do is give us a local repo with all those files from the remote GitHub repo. And you can see here it is, the Tiny-Yolo, fourth from the bottom of our list, Tiny-Yolo-3. So we're going to CD into that directory and browse around some of the files. And once again, these files we don't really need. It's what's an example. That's what we're going to run on the Raspberry Pi for now. The other files we'll need, but not for the Raspberry Pi. So I'm going to go to example. So this has the YOLO main that we need, and it has an images folder where we'll put our source images, and the results from running the program will be in our out image folder. And YOLO main, it's everything we need, but we need the actual Tiny-Yolo 3 h.file model. So we're going to create that model using this Google Colab notebook. So we're going to go back to the GitHub, click on the Tiny-Yolo notebook, and that takes us to the README for that. And once again, you can click this link and go to our Facebook page and like it. Make sure you do that. And then this is just showing some of the results before and after of processing images using Tiny-Yolo 3. So once again, we'll lose some accuracy, but it's a good object detection thing to start off with. So we're going to click on the notebook. This is a Google Colab notebook. So a Google Collaboratory notebook is all it is it's a Jupyter notebook environment. It's pre-configured and it can be used interactively to develop our machine learning workflow, and also you can collaborate with it on it. So we're going to click the open in Colab, and this is the actual notebook, Jupyter notebook in the Google Collaboratory environment. So you can see here it gives us a table of contents here to the left, and on the right is our actual notebook. So the notebook is divided up in cells, and there's two types of cells: code cells and text cells. So text is where I put like my notes and headings and things like that, and code is where the actual Python code is. So that's what we'll be running. And you can see it's not connected to an environment yet, so when we either select our folder or we click on this connect here, we can do that. So here's the table of contents. So when we're clicking on any of the headings in the table of contents, takes us to that cell in the notebook. So I tried to organize it so that the headings, each cell has a heading that you can access easily in the table of contents. All right. So this one's here. This is some of the code for the object detection. So you can just browse through that. And like I said, this model creates the Tiny-Yolo layer by layer using the Keras and TensorFlow on the back end. So this allows you to get under the hood and kind of customize the model however you want. All right, so now that we have that, we can browsing through the code, the different parts of the code. So we have, once we create it, we're going to construct the model. We're going to load it back into our notebook, and then we're going to run a test, and then we'll download it. So right now, I clicked on the folders tab on the left-hand side navigation bar. So this is where we'll see like the contents of our file system. So this gives us a temporary file system. All right, so right now I'm running the one that said important. So what this does is installs the correct version of TensorFlow. So it's a little different from the one we have on a Python, but it still works. So once I do that, I'm going to restart the runtime. And once I do that, I'm going to click to the cell that says start here. I put my cursor there, and then I'm going to click runtime and run after. So this run after runs all the cells, including the current cell down to the end. But you can also run each cell individually if you want. But so once it's run, it runs an actual like prediction on our image. It runs the Tiny-Yolo. So this is the results. We get an output. So this is what it's going to give us: output, what it detected, and this YOLO test.5 miles. So if you right click on that, do download, and then you can download it directly to the Raspberry Pi. And once again, if you're running a Raspberry Pi in hitless mode, you can do it that way also, but you'll just have to do this step separately, generate the model and copy it over from a different computer. All right, so now we've downloaded the YOLO test.h5 file. So now when we run Python 3 YOLO main Python, it's gonna use that model to do its prediction. So here are the results. In the image, it detected the dog, a bicycle, and a car. So once again, you could use your own images to test, but make sure you put them in the images folder, and you will have to modify the Python file to the name of the file you want. I don't have any command line inputs right now for that. So that was the input file, and now we're going to look at the output file to see what happens after we run it. So after we run it, it puts a bounding box over the objects it detected in the image. And once again, this is kind of like Tiny-Yolo, so it's not as accurate, so it may miss some things. But that's what this algorithm does. So that's how you run the Tiny-Yolo model on the Raspberry Pi. And once again, go to blackmagicai.com, and you can find the links to like us on our Facebook page, and also you can subscribe to our YouTube channel.